Okay, so we are, this first class, going to do a review from everything you would have looked at in Chem 20. We're more or less going to just look at the formulas, remember how they work, and then look at, like, harder or, like, tougher problem-solving questions than you would have looked at in in Chem 20. So, these are the first, or I'll just get them all up here. So there's all the formulas, oops, too far. So pH plus POH equals 14. So if the pH of something is 2, the POH is 12, right? They both should total up to 14. The pH, to figure out the pH for POH, we take the negative log of the, where this right here is the concentration, right? Concentration. And if you need to figure out either the hydronium ion concentration or the hydroxide ion concentration, it's 10 to the negative POH. And if you remember anything from Math 30-1, Math 30-2, base 10 and logs, like 10, power of 10 and log would be reciprocals of each other. So the formulas do mathematically make sense. So you have to remember those, but really you kind of only need to remember like two formulas. Like when I do this, I just remember pH slash POH is equal to this slash the OH formula, or the hydroxide or hydronium ion concentration is equal to the pH slash POH. And remember, this is not actually hydrogen. When I cut it, that's what it looked like. It should be hydronium ion concentrations, because hydrogen ions don't exist on their own. We also have to remember the SIGDIG rule for this. So significant digits for concentration just follow the regular concentration rules. Significant digits for pH or POH follow the decimal point. So if you had, a concentration of 2.00 moles per liter, and you change that to a pH, whatever it was, you have to make sure it was, if it was 2.500, those 3 digits go after the decimal. So something to pay attention to if you're doing like a written response or something. I guess in terms of the diploma, it won't come up, but for our purposes. And make sure, like, in these step-by-step equations that you keep that randomly trailing decimal in your calculator. If you don't do that and you round it, and especially because we're dealing with like reciprocals here, it changes your answer quite a bit. So make sure you're keeping that on your calculator. Does everybody have all those down? Everybody remembers those formulas? Yep. Okay. So just some things to remember. I didn't mean for this to pop all up all at once. So some things about acids. They taste sour. They should turn blue litmus red. They have a pH less than 7. They should neutralize a base. And they always react with active metals to produce a hydrogen gas. And you would have seen the reaction, Mr. Shelley should have done it, where you take like magnesium or zinc, add it to hydrochloric acid, and you produce hydrogen gas, which you can light on fire. Yeah, like you collect it in the balloon and then light on fire. So this is this. If you're writing that down. Information about bases. Bases taste bitter and feel slippery. They have a pH greater than 7, and they would neutralize acids. And this whole unit we're looking at to figure out how much they would neutralize by, to figure out how much they would dissolve in water, what's the equilibrium constant, how can you figure out concentrations given that information. That's what we're going to be looking at here. Strong acids, so when you did the acid-base unit in Chem 20, you look at the difference between strong acids and weak acids. Strong acids are these guys listed right here. They ionize or react with water at a 99% rate. So really, they are like a complete stoichiometric reaction. They go all the way. Stoichiometric, or like what you might see is called quantitative. So you just have that one-way directional arrow. Strong acids don't have an equilibrium arrow because they're only going to produce hydronium ions and their corresponding anion. Strong acids, not something you need to memorize. You can it's good to be able to identify them. But if you're not sure, right, these are the top 6 on the acid-base table. Which, if you're looking at your data booklet, is just on page 8-9. Right? So the top 6 here are the strong acids. They will ionize completely 100% with water. Weak acids, they have to react with water to produce the hydronium ion. They're always reacting at a lesser percent, and usually the reaction rate is less than 50% complete. And they always should be reacting with water, so they partially react with water. And that then, on your acid-base table, is all of these acids stacked here. Did you guys, you looked at like what happens or how they react with water last year? Take this acid or this base, put it in water, what's it going to produce? You guys done that last year? Maybe? Okay, well, we'll, I guess, get there. So today we're just going to look at these formulas. So a few basic questions first, and then we'll do the tougher ones. Am I good? Okay. Oh. Okay, so these are the most basic questions you would have looked at last year, and then we'll get to the tougher ones. So find the pH of a solution where the hydronium ion concentration is 4.7 times 10 to the negative 11. Just looking at this, based on kind of some of the stuff we did yesterday, do you think this is a strong acid or a weak acid? Weak acid, right? That 10 to the negative 11 indicates that that's a very small number or concentration. So to figure out the pH, what I need to do is that pH is equal to the negative log of the hydronium ion concentration. And so I would just insert that number right here. So the negative log of 4.7 times 10 to the negative 11. My units that I should include there are mole per liter. So if I put that all in my calculator, negative log of 4.7, let's see what I get here. Negative, where's log? Log. Oh, come on. Gives me 10.3279. Now, when I'm reporting my pH here, I need to make sure that I'm doing the proper SIGDIG rule. So SIGDIG rules would be after the decimal, so there are 2 in total here, so I need to put 2 numbers after the decimal, so this would be 10.33 as a pH.
Well, isn't there only one number after that decimal, so that would only be...
No, because it's the total number here,
okay.
Which is significant after the decimal for pH.
Wait, just for pH?
Just for pH. Everything else follows the regular...
So if I was 3,
Yes, yeah. If it was 17.4, then you'd have to go 3, 2, 8. Okay, so calculate the hydronium ion.
SIGDIG and, pH doesn't have a unit.
No, just the pH is blah, 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 yeah. Calculate the hydronium ion concentration if the pH is 5.2. Now, these two directly correlate. You kind of always have to make sure for that, because sometimes they might give you POH and ask for the hydroxide or hydronium concentration, right? So those two directly correlate, and the formula I use is the reciprocal, or formula of that, maybe not reciprocal, but would be the 10 to the negative pH, so it's just 10 to the power of negative 5.25. So 10 to the power of negative 5.25 gives me 5.623 ... times 10 to the negative 6. So as a final answer here, with significant digits, how many SIGDIGs is this question giving me? So this is pH, right? So after the decimal, 2, gives me a total of 2 here, so 5.6 times 10 to the negative 6 moles per liter. Okay, so try this one on your own, and then we'll look at the harder question next. Give you a minute or two. I'm just going to put the answer for this one up here. Is that what everybody got?
Yeah.
This one. Should, and then,
Can you just give us a couple more minutes?
yeah, I'm just going to go move to the next one. Okay, so this question is more, I guess, to the level of Chem 30 and the problem solving that we are going to be having to do for questions that deal with this kind of stuff from Chem 20, where you have to take kind of everything together and put it in one question. So calculate the pH of a solution. So ultimately, I need to know, what is the pH? And they give me mass of calcium hydroxide dissolved in 500 milliliters of water. Now, in order for me to get to pH, I need what?
Your concentration.
I need the hydronium ion concentration, right? Do I have the concentration of that? No. So then what do I need
If
to
it
do?
is the pH of a solution, could it just be your, rather than your POH, your pH of your OH? So right
So
now
I
you're
get what
converting
you're
everything
trying to say.
around.
I get it.
Okay, at least you get it. Because so you're trying to calculate your pH of a
Yes.
solution.
Yeah.
So you can convert your POH to your pH, correct? So then you can find your pH of your OH concentration, correct?
Oh, yeah, I don't, yes, so I see what you're saying. I don't really need this, because I can figure out this, and then go to POH, and then go to here. Yeah. Okay, so then, but I still don't, the problem, regardless of which way we go from it, I still need what? Concentration, and I don't have concentration in moles per liter, but I do have, I can use N equals M over M, and then go into C equals N over V. So the number of moles in 10.3 grams over the molar mass of calcium hydroxide
74.1.
is 74.10 grams per mole. Am I not right?
Yeah, you're right. No, you're right.
Okay, 0.139 moles.
Times it by 2.
Right, why?
Because
you need the OH, not the whole thing.
Right, this is the number of moles in the CaOH. I need to know if I put this in water and it disassociates. Well, there's only one calcium ion, but there's technically 2 hydroxide ions. So I use my stoic to times it by 2 and figure out the number of moles of calcium hydroxide is actually 0.278 moles. Then I take that and put it into C equals N over V. So I'm looking for the concentration of the 0.278 continuing moles over the volume of 0.5. Always change that from milliliters to liters. And so the concentration is 0.556 moles per liter. And this is the concentration of what? That's the concentration of what? My hydroxide ions, right. So this is my hydroxide ion concentration. But they're asking me for pH, so I need to take that and do what? Right, find my pOH and then minus it from 14. So to find the pOH, I would go pOH is equal to the negative log of the hydroxide ion concentration. So I take the number we just figured out, the hydroxide ion concentration is 0.556 moles per liter, which gives me 0. Something, right? 0.254, blah, 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 right? 0.254. And then to figure out the pH, it would be 14 minus the pOH, I guess if you rearrange here. 14 minus 0.254. This question has 3 sig digs, so my concentration has to have 3 significant digits after the decimal. So the pH is 13.745. 745. Well, because if I think about this, calcium hydroxide, anything that is a ionic, like a metal combined with hydroxide, is always a very strong base. It's really just like a one-way directional arrow. It's completely going to dissociate to produce hydroxides. Really, the only reason that there's any hydronium in there is probably due to the water, right? Not because we're creating hydronium ions. Okay, so that's what we're doing for the end of for this class. So you're going to do homework 4, 7 to 10. That is the way that you should have done it. It was just the way that you said it. Just sounded, yeah. It was just the way.
Everyone was just like making fun